Okay, this is second semester, 7th grade math, unit 3, lesson 1, vocabulary review. The additive inverse of -8 is what? What's the additive inverse? Hola. Positive 8. Very good. Or you could have just said 8. Okay, and the reason why they're called additive inverses is because two numbers whose sum gives you back 0, those are additive inverses, right? Isn't -8 plus +8, isn't -8 and +8, doesn't that sum give you back 0? Okay, well, you'll learn more about that a little bit later. Okay, so can somebody tell me what is -3 plus 3? What's that going to be? Jonathan? 0. What's -3 plus 2? Who's got that one? Yes? -1. What's -3 plus 1? Who's got that one? Somebody I haven't heard from yet? Rudy? It's going to be -2. And then what's -3 plus 0? Who's got that one? Timothy? That's -3. And then somebody had said that they noticed a pattern. So if you looked and we listed these numbers, 0, -1, -2, -3, there is a pattern emerging here. If this was my first, and we're going to call it term, and this is my second term, and this is my third term, and then obviously this is going to be my fourth term. Can you predict what the fifth term is going to be? What is my fifth term? Who can give me a guess? Alexandra. I mean, what is it? What'd you say? -4, and that's a pretty good guess. And I agree with you, -4. And how'd you come up with -4? How'd you come up with that? Right. So she just said each number, and you're talking about each term, to go to the next term, you decrease by 1. So the rule would be -1, and this is the rule. Okay? So each term, you can use the rule to find out the next term. Okay? And let's go ahead and see what this whole lesson's about. I'm going to go ahead and read this since I want this to be on the message board and the YouTube channel. What you'll learn: to describe the patterns in arithmetic and geometric sequences and use the patterns to find terms. Okay? And so I wanted to explain what a term is in the warm-up. So we're going to learn some more about it. New vocabulary: sequences, arithmetic sequences, geometric sequences, conjecture. Why learn this? Some patterns are found in nature. If you can recognize a pattern in a list of numbers, you can make predictions about how the list will continue. And if you notice, Alexandra, she had a prediction, right? Based upon the list of numbers, she had a prediction, and she predicted the fifth term. Okay, and then but before she predicted the fifth term, she had to recognize what was the pattern or the rule that took me from one term to the next. Okay, so let's take a look at the first vocabulary word we're going to talk about: a sequence. A sequence is a set of numbers that follow a pattern. Each number in a sequence is called a term. Okay? The set of numbers 1, 3, 5, 7, 9 has a pattern. If you add 2 to any number, you get the next number in the set. Does that make sense? So in our sequence we saw earlier for the warm-up, what was the pattern we saw? Do you guys remember? What was the pattern? It decreased by 1, so the pattern was subtract 1 to go from one term to the next, right? So here we have a sequence, and here it's not subtract. What's happening? The operation for the rule is what? We're adding, and we're adding how much? 2. So each term, the rule is add 2 to get to the next term. okay? So if we wanted to, what would be the term after 9? It would be 11. That would be my next one, right? Okay, and we could continue to figure out each following term after 11. Right? Now, in an arithmetic sequence, you find each term by adding a fixed number called the common difference. So you can add a positive number or you can add a negative number. Does that make sense? So the sequence that we saw in the warm-up, that's still an arithmetic sequence, even though it's subtracting 1. Okay, we can think about it as the common difference, or the number we're adding by is a negative number. Do you understand? So an arithmetic sequence is a number where you're adding a number to get to the next term. And that number can be a negative number. Do you understand? So to say that more simply, if you're adding or subtracting the same number to get the next term in the sequence, that is an arithmetic sequence. Do you understand? Now, Caleb, earlier, before we started the warm-up, you gave me another type of sequence. We're going to get to that here in a little bit. Any questions? Questions about what I just covered? Yes? You already left out. Now, describing an arithmetic sequence. Describe the pattern in the sequence below, then find the next 3 terms in the sequence. So when they say position 1, they're really saying that this is the first term, right? Do you guys understand? That's the first term, and then the second term, third term, fourth term. Okay, now what I need you guys to do is you need to identify the pattern, see if there's a rule that takes me from one term to the next, and then apply that rule to get the next 3 terms in the sequence. So first of all, does somebody recognize a rule here? Joseph, what's the rule? Joseph says -5 is the rule. Do you guys agree with Joseph? -5? So from the first term to the second term, I agree, the rule is -5. And does that rule work for every term? Yes. From one term to the next, does that work? Yes. So 7 minus 5, does that give me 2? Yes. 2 minus 5, does that give me -3? Yes. So how do I get the next term, which is going to be the 5th term? What's the 5th term going to be? So we want the 5th term, the 6th term, and the 7th term. So we're going to continue this table, and we want to know what each of these terms are going to be. And I hear some people calling out, so I would like to call on some people to tell me what the other terms are. Okay, so I heard somebody call. Can I get a volunteer for the 5th term? Who's got the 5th term? Oren. -8, correct. Okay, because -3 take away 5 more gives me -8. Who's got the 6th term for me? Somebody I haven't heard from. Alexandra, go ahead. -13. All the way in the back. Joshua, can you give me the 7th term, the last term that we're supposed to find? -18. Okay. So far, what do you think? Pretty easy stuff? Yes. Okay. It's gonna get hard. It will, but if we take it in little chunks, I don't think it's too tough. Now that was the one I kind of worked out with you. I want you guys to quietly on your own describe the pattern in the sequence below, then find the next 3 terms again. So I just did one with you. This is one for you to do on your own, and we'll talk about the answers. So what I need you to do is write out this table and then leave some blank spots for the next 3 terms in the sequence. And just a really quick side note for you guys. Sometimes this is called a T-chart. Do you see the T? Okay. And so you'll have the position, and then you'll have the value, okay? And so this is just a sideways t-chart. And so I'm just going to fill in the values. So I have position 1, 2, 3, and then my first term was 44. My second term was 35, 26, and it continues on, right? Okay, so if I were you, you don't need to make a nice pretty table. You can make a t-chart. You can even make a t-chart sideways. So you could have done the same thing. And do you see how my t is sideways? Do you guys understand? So whenever you hear somebody talking about a t-chart, that's what they're saying. They're saying a table where you have two values. Yeah, does that make sense? So who's going to give me the next couple terms? I'd like somebody to give me the 6th, 7th, and 8th term in our table. Okay. Well, first of all, what is the pattern here? Who can tell me the pattern? Somebody I haven't heard from yet. Thank you, Fatima.
Well, I kind of see a pattern that in the tens place it decreases by 1, and in the ones place it increases by 1.
So if you're looking at the first term, we have 44 and then 35, right? So what's the, remember we're talking about arithmetic, what are we subtracting? 9. But you're looking at the place values and looking at the patterns there. Now we're talking about arithmetic sequences, so we're talking about we're either adding or subtracting the same number from one term to the next to get each following term. So you just said the rule. What's the rule? You're going to decrease by 9. So your rule is minus 9. Okay? And so can you tell me the 6th term? Well, if I have 17, I take away 9, that gives me 8, right? Okay. So now I got to say 8 minus 9 to get correct, -1. Does everybody understand why it's -1? Yeah. Okay, who can give me the next term, term 7? Jonathan, thank you. -10, very good. And then who's got the last term we're supposed to find, which is the 8th term? Can I get a volunteer for that? Terrell? -19. Pretty easy, right? Okay, moving on. Now, this is the sequence that you gave me earlier, Caleb. I said it wasn't an arithmetic sequence. Let's go ahead and read this. In a geometric sequence, you find each term by multiplying the previous term by a fixed number, called the common ratio. In the sequence 2, 7, 24.5, 85 and 75/100ths, you multiply each term by 3 and 5/10. Okay, so you're multiplying by a number. It doesn't have to be a whole number. Do you understand? All right, so let's take a look at this next example. It's a little bit easier geometric sequence. Okay, describe the pattern in 27, 9, 3, 1. We're going to find the next 3 terms in this geometric sequence. So can somebody tell me, and I'm just going to really quickly make a t-chart. Here's my t-chart. And I'm going to say the top is going to be my term. So I have my first term, my second term, my third term, my fourth term. And they give me the first 4 terms, right? And they want us to find the next 3. So I'm going to need the 5th term, the 6th term, and the 7th term to fill up my t-chart. So the first term was 27. The second one was 9. Then it was 3. Then it was 1. And now we got to figure out what's 5, 6, and 7. What's the 5th, 6th, and 7th term? So before we can do that, we got to recognize what is the rule. And we're already given a big hint. They tell us this is a geometric sequence. Okay? So that means that we are multiplying by something. It doesn't have to be a whole number. Okay, so can somebody tell me what is the pattern here? Carter, thank you. You say divide by 3? I agree with him. So we're gonna, how would I think about that as a multiplication though? What do I be multiplying by? I think I heard it. Who said it? Multiplying by what? 1/3. So if you're multiplying by 1/3, right? Isn't that the same as dividing by 3? So if I multiply 27 times 1/3, that's 27 times 1 gives me 27 in the numerator. And then over 1, 27 over 1 times 3 gives me, so 27 over 3 gives me 9, right? So if this is my rule, what would my next term be, my fifth term? So I'm using this rule over here in blue. What would my next term be? I got to take 1, and I need to multiply it by I need to use that rule to find my next term. Ola, what do you got? You guys know what 1 times 1/3 is. Come on.
1/3.
It's just going to be 1/3. Now, guess what? I need to find my next term. So how do I find my next term? I take the fifth term, and I use my rule again. And you guys, last semester, I said that's the easiest operation to perform on fractions, multiplying fractions. So what's my next term going to be? 1/9, because 1/3 times 1/3 gives me 1/9. Okay, and then what's my seventh term going to be? Who's got that one?
1/27.
Very good, 1/27. All right, so here we go. Don't get intimidated by the big numbers. This is an easy sequence. Go ahead and figure this out. Shh, don't call out. I want you to make a T-chart. Then I want you to fill in the information they give you. I want you to identify the pattern or the rule. And then I want you guys to fill in the 3 terms that are missing. Most of you are following directions. There's a handful of you that don't even have paper out. You're not writing. It's not going to stick if that's how you're going about it. Okay, my first term is 1,000. My second term is 100. My third term is 10. They want us to find the next 3 terms, so the 4th, 5th, and 6th term. Now, before we can go about finding our next terms, I have to identify a pattern. Who can tell me what the pattern is? Olamide, what's the pattern?
Divide by 10 or multiply by 1/10.
Nice. So we want to talk in terms of what are we multiplying by? You recognize, hey, I'm just dividing by 10, but how do I write a division as a multiplication? I'm going to multiply by 1/10. Okay? Now we can go about figuring out the rest of my terms. So if my third term is 10, and I multiply that by 1/10, what is my 4th term going to be, Glorabel? It's going to be 1, because 10 over 1 times 1/10 becomes 10 over 10, which simplifies to 1. Okay? Now my 4th term is 1. Now I got to find my 5th term. What's my 5th term going to be? Timothy. We're multiplying. I have a positive 1, and I got to multiply by 1/10, and that's positive. So the sign's not going to switch because they're both positive. It's just going to be 1/10, because 1 times 1/10 is 1/10. Now I need to figure out what my 6th term is. Who's got my 6th term? Abu, I haven't heard from you for a little bit. Go ahead, tell me what's it going to be. 2/10. We're multiplying. Saki, can you help him out? Nice, because you take a 10th and you multiply by the rule, which is 1/10. That's going to be 1 over 100. Good. Any questions? Any questions about this, Carter? After Timothy gets back. Okay, moving along. Okay, a sequence is neither arithmetic nor geometric if there's no common difference or common ratio. Okay? If it doesn't have if there's no common difference or a common ratio from one term to the next, it's not geometric, it's not arithmetic. Okay? A conjecture is a prediction that suggests what you expect to happen. When you describe a pattern in a sequence, you are using inductive reasoning. So for the warm-up, Alexandra, she took a guess on the next term, and she recognized the pattern. So she had a prediction, a conjecture, okay? And she used inductive reasoning to come up with the rule so that she can figure out the next pattern, the next term in the sequence, okay? Now, geometry. What I want you guys to do is take a look. We have a pattern here, okay? I need you to describe the pattern to find the number of circles in each figure. So we have the set of 3 dots here, and then we got the set of how many dots? So let's identify what's happening. We have a figure, and we're gonna identify some things. How many circles do we see in this first figure? We see 3. How many circles do we see in this next figure? We see 6. And then how many circles do we see in this figure? 6, 7, 8, 9, 10. And then what about here? It's 15. So do you see a pattern here? So first of all, let's see what happens. What happens from here to here? What's going on? You're adding 3. Shh. And then from here to here, what's happening? You're adding 4. And then from here to here, what's happening? Now, do I have the same rule from one term to the next? No. There is a pattern, but I don't have a common difference, and I don't have a common ratio. So which one is this? Is this arithmetic, geometric, or neither? It is neither. It is neither geometric or arithmetic. There is a pattern, but it's not an arithmetic sequence because an arithmetic sequence says there's a common difference. So if I added 3 to the first one, I'd have to add 3 to each term to get the next term. That's not what's happening.
That's what I did.
And then a geometric, no, yours was different. A geometric says we're multiplying by something. What you did earlier was not quite it.
One and then add another. I just added 1 to the thing.
Yours was a pattern, but it wasn't arithmetic or geometric.
Yeah, it wasn't either.
Right.
I'm saying that's what I did. What's on the board? Oh.
You had a pattern, but it wasn't an arithmetic or a geometric pattern. Right, so we're agreeing. You didn't have an arithmetic pattern or a geometric pattern.
I did something.
But patterns exist that are not geometric or arithmetic. So you need to be able to identify types of patterns. So here's what I need you guys to do. Here's the quick check. I need you to take a look at these sequences, and I need you to identify if they're arithmetic, geometric, both, or neither. Say that. Shh, quietly to yourselves. Click save. Those are the ones we did in class. You can have sequences that are both arithmetic and geometric. It is possible. Logan, if you could put your things away and put your desk back, please. Okay, so the first set of numbers, what do you think? Who wants to volunteer to answer the first set of numbers? Ola, what's up?
First you add 1.
Okay, so you're saying there's a rule. For the first one, right, we added 1. Did we use that again?
No.
No, what do we do for the next one?
We added 4.
For the next one, you said you added 4. Okay. plus 4, and then what happened?
Then you added 16. Oh, no, 18.
Think before you see.
Just say times 3.
I say enough times 2 times 3 times 4.
6 times 4 is 20.
So, this is Ola's question. If you want to contribute, please raise your hand. So Ola, okay, you're looking to see, Ola's trying to see if this is what type of sequence. Is it an arithmetic sequence? No, it's not an arithmetic sequence. Okay, but now we want to say, what other kind of sequence are we trying to see if it is? Okay, let's see if it's geometric. Do you think it's geometric? Did somebody test to see if there's a common factor from one to the next?
I did.
What do we have?
Times 2.
Okay, so here we multiplied by 2.
Then times 3. And then you multiply.
Oh no, I keep on thinking about division.
But does that mean it's a geometric sequence? It's not geometric. So it is neither. Now who wants to talk about this next one? Caleb, what do we got? Shh. I don't know why I have the side conversations. I have called on one student. I need to hear that student. Is there a common difference here? What's the difference between the first term and the second term?
2 plus 1.
Okay. What about 3 to 6?
You have to add 3.
Okay. What about 6 to 11?
You have to add
5, right? Is that arithmetic?
It's not.
Logan, slide back too. It's not arithmetic. Okay, is there a common ratio? What would I multiply 2 by to get to 3?
You can't multiply anything to get to
1.5, wouldn't I get it? How do I write 1.5 as a fraction? That's a mixed sign. 1 and 1/2, write that as a fraction. 1.5, write as a fraction. What is that? Shh. How do you write the mixed number 1.5 as a fraction? Shh. So, please stop talking. If I take 2 and I multiply by 3/2, doesn't that give me back 3? Okay. Well, will this work for 3 to 6? If I multiply 3 times 3.5, does that give me back 6? No, what does that give me back? Doesn't that give me back 9/2, which is 4.5 or 4.5? So does this qualify as a geometric sequence?
No.
It's not geometric. Okay, and then the last one over here. What's happening here? -1, -1, -1. So, is it an arithmetic sequence? Yes, arithmetic. Is it geometric? Not geometric. Okay. A pattern for a sequence is described as start with 12 and divide by -4 repeatedly. Is this a geometric sequence? Start with 12 means my first term is 12. And then we divide by 4 repeatedly. Is there a way we can clean that up so it would be correct? How would we fix this? We can fix this and make it a geometric sequence. How would we fix it? The first term is 12. Each following term follows what rule? What's the rule? Right, so how would I create that? So let's do it. How would I turn a divide by -4 into a multiplication? Multiply by what? Multiply by negative. So multiply by -1/4. Now that's going to give you a funky sequence, but it is a sequence, and the sequence is going to go back and forth because you're going to have positive and negative numbers, right? Okay, that's called an alternating sequence. Can two different arithmetic sequences have the same common difference? Yes. Give me an example. So yes, and here's an example. I'm going to show you two. Same common difference. 0, 2, 4, 6. What about this? -1, 1, 3, 5. Don't they have the same common difference? What's the common difference? Plus 2, right? Okay, so they're different sequences, but they have the same common difference, right? Okay, what is the common difference of this sequence? How do I go from 35 to 29? Minus 6. How do I go from 29 to 23? Minus 6 again. And then does it work for 23 to 17? Yes. So the common difference is -6. Subtract 6. Or add a -6. Okay, finding the missing term in each sequence. First sequence, I need to find the missing term. What's happening?
Add 7.
Okay, I hear we're adding 7. Does that work for the second term?
Yes.
It looks like it does. Plus 7. So what's that missing term going to be?
27.
Right, 27. Okay, and then does that work for 27 to 34?
Yes.
Okay. All right, so what about this last one? 100, and then I got 50. What's going on here?
Divide by 2.
There you go. It's not subtract 50, it's divide by 2, but how do we word that as a multiplication? Multiply by 1/2. So if we're multiplying by 1/2 each time, what is the next term going to be here? Right, half of 25 times 1/2 is 25 over 2, which is going to be 12.5. Very good. Okay. So, any question about that?